And so you want to look at those proving identities. Remember, on proving identities, you don't want to cross that. That line. I don't know. I haven't practiced this one, so I'll try it. Maybe I won't get it done. Page 213. So I'll look at 50. Secant. Remember that you don't treat this as an equation. You don't cross that, like multiply the same number of times both sides and all that. You have to work with one side with, and usually what they suggest doing is work with the most difficult side to try to reduce it down. To remind me that if I get it to this point, right, tangent is sine over cosine. So if I can work this thing down to this point, then I've got the identity proved. And I guess there's always, if you don't see something right off, you always go with turning everything into sine and cosine. So
secant tangent squared. Oh wait, that's
no. If you squared this, it would be secant squared minus 2 secant tangent plus tangent squared. That would be a possibility there. And the secant squared plus 1, there's an identity that, yeah, I'm just mulling around in my head to see whether I can see anything that's going to, where I might want to go. You go back and look at your identity. That identity sheet should be something that, see, if I squared this out, I could go tangent squared plus 1, get secant squared, then I would have 2 secant. I don't know whether that's going to, this thing here in the denominator, I could common factor a cosecant out, right? And have a secant tangent. Maybe let's go ahead and do that. Let's expand this out, numerator into, it'd be secant squared theta. The middle term would be 2 minus 2 times the product of the secant tangent. And then the last term would be plus tangent squared. Then I would have this plus 1 in the numerator. This thing, if you look at your identity, the possibilities, you could replace tangent squared plus 1 with secant squared. I don't know if that helps us any. This one, notice there's a cosecant in common in both. So I could write this as cosecant theta times secant minus tangent. I don't know whether this is helping me any. let's do this. Let's replace that numerator. I think I can, I think that I can have two secant squared, factor a secant out, and then have a secant tangent and cancel this. I think that's where it'll go. I'm just going to rewrite this. And then substitute the identity for tangent squared plus 1 is that secant squared. That's on your sheet. The denominator is cosecant times secant minus tangent. This one and this one is 2, right? 2, numerator is 2 secant. This is supposed to be theta squared theta minus 2 secant theta tangent theta. We got cosecant times secant. Now see in the numerator, if I factor a 2 secant out, I'll have a secant tangent that'll cancel with this, right? So if I factor out 2 secant theta, then this becomes secant. Then I have a minus tangent. In my denominator, I have cosecant. I'm there, right? See this cancels with this, and then this thing is going to be 2. This is 1 over cosine over 1 over sine. So this is 2 sine over cosine. And then this one is identical with that. And I've shown my identity. That's what you just got to mess around with it until you get there. You all saw it way ahead of me. Did you all see it way ahead of me?
No.
But you see how it's just like I say, you know, there is no exact science to it. It is just, you just kind of say, oh, if I do this, what will happen? And that's the way all those things are. Do you want to try another one, or they all just get more difficult as we go further down? I haven't tried anything, so it's real dangerous of me to try something. Your algebra skills, along with your trig identities, and remembering those are real important on these. Which one do you want to try? Which one looks like a challenge to you? Which Chris?
Oh, sorry.
Chris Jensen? So which one should we try, Chris?
Trying to find one that needs both sides.
Yeah, well, anything beyond where we're at is kind of like a both side deal. Well, except like 60 is probably a one-sided thing. 66. Sometimes the hardest ones turn out to be the easiest. Not necessarily, but just sometimes. Cosecant. You know what this thing looks like me? This looks to me like cosecant minus cotangent the quantity squared. That's the first term is squared, the trailing term is squared, so this is cosecant, cotangent, in the middle is 2 times the product of the two. You see on that identity sheet? You know, this thing is, I don't know whether this will help us. But cosecant x minus cotangent x, the quantity squared. See, it's the first term squared minus 2 times the product of the first times the second plus the second term squared. That's what this is written, so that's what this is. And I don't know whether that helps us or not. See, this is 1 over sine, and that is cosine over sine. Would be yeah. Yeah, I don't know. I'm not want to always keep this in mind. Let's just try this. Let's try putting 1 over 1 plus cosine. I don't know why this thing gets that way. Minus. I mean, we can write that this way. 2. I don't know if that helps. Another way of looking at this is this thing would be 1 over cosine, isn't it? 1 over sine. Minus, we just write this all in sine and cosine. 1 over sine. Then this is cosine over sine. And then this is cosine squared. Now then, that numerator, you know, if we put this all this way, I'm just fiddling around with it. If we just write 1 minus 2 cosine x plus cosine squared x all over sine squared x. This is 1 minus cosine the quantity squared. You see, we're getting close to that original thing, right? Cosine x the quantity squared. That's the way that would expand, right? Oh, maybe here. Over sine. This sine squared I can write as 1 minus cosine squared, can I? correct? Then this is 1 minus cosine x, the quantity squares. This is a difference of squares, so I can factor it into 1 plus cosine x. I'm getting really close here. 1 minus cosine x. Correct? And then notice this goes out with one of these and makes this to the first power. And there it is. That's that first thing right up there, right? I have 1 minus cosine x over 1 plus cosine x. So my first try here was kind of not a good start. So I resorted back to doing everything in sine and cosine, and then what it is, it's your algebra skills. No one knows algebra identities and your trig identities.
Unfortunately,
Yeah.
if it relies on my algebra skills, it's a big problem. But
Yeah.
this sheet helps. It's a good
Yeah.
reminder.
I tell you, these things are really hard. These are hard. I remember when I first started doing them, and I mean, I sometimes now I get stumped. But do you want to try another one, or onward and upward? What do you want to do? I want to get through the next section. If we don't get through it today, we'll get through it Monday, and then that'll probably be as far as we go. Then we need to proceed on with other stuff.
Is the next section something a little different?
Yeah, it's the sum and difference identities. It'll kind of give you an idea of how the rest of those things chapters work, where it's the cosine sum and difference, then you'll have sine sum and difference, and then you'll have double angle identities and half angle identity. It's all kind of like what's next section.
Let's try that.
Okay, you think you can, if you struggle with some of these things, these identities, and then, you know, I would say practice with them. Try to get, that'll frustrate you to death. And you know, you could try a few, and then if you have difficulty, we can come back in. And if you try them, and then we come back in Monday, and then I do them along with your help, then that'll really help you learn them. So if you try, you know, a couple, 3 at least of the ones, and if you can do them, fine. If you can't, and you get stuck, then I can help you with them. Now, I'm not going to try to prove this identity. You can look at it and see that on 215, it's showing you why this identity on the bottom of page 216, where the cosine of the sum of two angles equals the cosine of the first angle, cosine of the second minus the sine of the first, sine of the second. It is that way. It is an identity. You can substitute one for the other. And then the difference of cosine is that other one. Then there's cofunctions, and a sine's cofunction is cosine. Cosine's cofunction is sine. And then secant and cosecant are cofunctions, tangent and cotangent are cofunctions. And what it is, if you have the sine of an angle, then it's equal to its cofunction's complement. And the complement is what? 90 minus the angle. So if you have sine of 30, it's equal to cosine of 90 minus 30, 60. That's cofunction. Cofunction, complement. The complementary angle. And the complementary angle is the angle for which, you know, the sum of the two angles equal 90. Does that make sense?
Let me see it sort of written down.
Okay. Well,
not drawn out necessarily, but.
Okay,
first
the thing that, what you can see was with the angles that we have, see, sine's cofunction is cosine. So whatever you put here, if you would put sine 30, then this you would go 90 minus 30 degrees.
Sure, okay, we've done that before.
Yeah.
That makes sense.
Yeah. So this is the same as the cosine of 60 degrees. That's what it is. The way they write it in general, they say the sine of theta equals the cosine of 90 minus theta. That's the way it is with any cofunction. So you could go the other way around. If you did cosine of theta is equal to the sine of 90 minus theta, because they're cofunctions of each other, whichever way you go. And then the other cofunctions are secant, theta, and cosecant. And this is 90. And this is called the complement, the complementary angle. So it's the secant of an angle is the cosecant. It's complement of the complementary angle. And then it goes the other way, right? Cosecant alpha is secant, because these are cofunctions. All it's saying is you can just write them either way. And then tangent, cotangent, right? You go tangent, then it's its cofunction, cotangent, of its complement. And then if you have cotangent first, it's just saying that you can write these things either way, whichever one you have, tangent or cotangent, you can write the complement of the cofunction. Just I want you to look at something on 221. 221, and here's an application of using the material that we're learning in this section, and notice that what it is, it's talking about alternating current. So, these trig functions, that's where they're relating it to. It's alternating current. And they're talking about, I don't know, you can read through that, 115 volts and the angular speed and so on. But it's, that's where the trigonometric, these things work in that area. So, if you want to look at justification of why the heck you're learning these things, if you look at where they show you application, that's where it's at. We're just doing the math of it. We're not going to try to do the application. That'd be in electronics and physics that application would come in. So, you'd have to know this to be able to get in and do the electrical part. And, I know that I've talked to those guys down here in our electrical department, and, they talk about all these things to people that don't really know trigonometry. And it's really hard for those people to understand. I don't understand it because I don't know. I kind of get an idea what they're talking about. But anyway, so let's look at some of these problems. Take a look at number 1 on page 221. And it's just the identity. So Chris Earl is the guinea pig here. So cosine of the sum. Look at the identity. look at that identity for this. So what is it?
What stands out to me is probably A. That's probably mine.
Well, look at that sum and what is it saying? If you see that cosine of the sum and difference, cosine of A plus B, which is that top one in that box, right? Is cosine A cosine B minus sine A sine B. So which one is that?
So it's gonna be the opposite of that, so F.
Okay. So look at then Tyler. What is number 2? A, right? Okay, cosine of 90 minus x, James. Okay, it's a complement, right? It's complementary angle. And so, Chris, then what's the other one? Okay, yeah. All right, so the next one, it says use the identities to find each exact value. And it says do not use a calculator. So let's look at 6. This is cosine of minus 15 degrees. Now what you want to do is use the sum of angles and use the sum of a pair of angles for which we know the trig functions of it. And those would be what? Those would be, what angles do we know? We know 30, 45, 60, 90. What would be a sum or difference of those angles that would be minus 15? This is what? You would go 30 minus 45. That's a minus 15, isn't it? Now then, look at your identity, and your identity says what? The difference, the cosine of a difference, and I'm going to write this in red just so we're going to plug it in. Notice the difference is cosine A cosine B plus sine A sine B. And this one is A, and this is B. You see what I'm doing?
Not yet, but
Okay, see this cosine minus 15 degrees without using, I could put it in my calculator and figure it. But the only thing is they're saying don't do it. So what you have to do is you have to take a pair of angles that we have known values for. And the ones we have known is 0, 30, 45, 60, 90, right? And then try to figure out if you can get minus 15 as the sum or difference of those. And 30 minus 45 is minus 15.
so that part I understand.
Okay.
When we go to the red,
Okay, well, the cosine of a difference, and I'm looking back on page 216 or in your book, that cosine of the sum of difference. You see, that's cosine A, cosine B, sine A, sine B. I don't know. You see it on your sheet, or it's on page 216, bottom of the page.
and the top, or the top of the page, yeah. All right, I see
Yeah.
that.
All right. So, but now notice that A and B are both going to be positive numbers, because when you plug it into that, B a plus 45, you go a minus a plus, right? So A really equals 30 degrees and B equals 45. Don't put in negative 45 because I'm using A minus B, right? So I put 30 degrees for A, 45 degrees for B, and that minus would be in there, so, do you understand what I'm saying? Don't put minus 45, put 45. If we use the sum, then B would have to be a minus 45. And then we'd have to use that cosine A, cosine B minus sine A, sine B. We could do that. You understand what I'm saying?
Well, how? You can use-
See if I could use this equation, the sine of A plus B equals, and that'd be that first one, cosine A cosine B minus sine A sine B. But now here I would use A as 30 degrees and B as a minus 45 degrees. Then I would use this formula. Because I would substitute 30 in, and B I'd substitute a minus 45, and it'd be 30 minus 45. If I use sine A minus sine B, and I use A as 30 and B as a plus 45, then it's a positive 30 minus a positive 45.
Okay.
Do you understand? You just got to make sure that, yeah, Corey? Oh, this is cosine. I wrote the wrong thing. Yeah, thanks. This, I wrote cosine of A minus B. This should be cosine of A plus B. I was concentrating on, you could use different ones depending upon what you. Now what I'm going to do is I'm going to substitute into this or this, whichever one I'm going to do. Are you good with that now? Are we ready?
Yeah.
Okay. So no matter which way I do it, it should come out right. So I'm going to go ahead, being this is close, I'm going to substitute 30 and minus 45 in this side. I guess I'll substitute it. This is going to be cosine. I'll just do 30 degrees minus 40. Plus, this is, I'll write it. I should write it better. It says plus a minus 45. Because I'm doing A plus B, where B is minus 45. Then this is going to be cosine of 30, cosine of minus 45, minus the sine of 30, cosine of minus 45. Cosine of 30 degrees is what? Is it square root of 3 over 2? It's on the unit circle, 30 is up and the x value starts out at 1 and then it drops down. So it's 1 square root of 3 over 2, square root of 2 over 2 and 1/2, right?
Yep.
So this is going to be square root of 3 over 2. Now cosine of a minus 45, now that's going down, right? And that's going to be a plus the square root of 2 over 2. Your unit circle, you're here and you're going down. So the x value still remains positive, right? And that's a positive square root of 2 over 2. Yeah. And then it's minus. Now it's sine of 30, so we're coming up. That's going to be 1/2, isn't it? And then, did I put that up? This should be sine, right? It's sine 30, sine 45. I didn't pay attention, make sure I didn't. So now sine of a minus 45 is going to be a negative, right? Square root 2 over 2. So the denominator is all going to be 4, right? 2 times 2 is 4, 2 times 2 is 4. This is going to be, and that square roots go under, so this is going to be the square root of 6 minus, this is plus, right? Square root of 2. Now if I do it right, then that other one should be the same thing. Correct? If I do this thing, so let's go up there and put 30 and 45 in this one. Do you see what I'm doing? When I'm doing differences, I use 30 and a plus 45. When I use sums, I'm doing 30 and minus 45. Both of them are going to give me a negative 15. Both of them should give me the same answer. That's all I'm telling you. It's not going to make any difference which way you approach it. So I'm just going to do that. I'm going to put cosine, one of these red, because I'm using this one. I'm going to go cosine of 30 degrees, right? Cosine of 45 degrees. Because here A is 30, B is 45. And then plus sine of 30 degrees, sine of 45. Now 30 is the square root of 3 over 2. This is the square root of 2 over 2. Plus, this is 1/2, right? And that's the square root of 2 over 2. So the denominator is 4, and the first one is the square root of 6 plus the square root of 2. All I'm doing is I'm showing you you have to pay attention. Whichever way you use it, it'll work out right. It's just that I got to get a negative. I have to have a negative 15. So if I'm going to use the difference here, then I have to use a positive 30 and a positive 45. If I'm using a sum, then I have to use a positive 30 plus a negative 45. And then, this is my identity for the sum, and this one is my identity for the difference. And I'm doing it both ways. So there's no exact way that you do it. Does that make sense? All right. Now, notice on number 8, you see they're giving you a hint there that you have a minus 105, and they're saying treat it as a negative 60 plus a negative 45. Now, if you do that, what are you going to do? The cosine of the difference or the cosine of the sum? Cosine of the sum, right? Where A is a negative 60 and B is a negative 45. You see that, James? That's what that hint is.
Right.
Yeah.
Yeah.
Yeah. So I'm not going to do that one. So let's look at 10. Here's the cosine of minus pi over 12. Now here, rather than 90, we're going to use, what's the equivalent? Pi over 2, right? So you're going to be doing something like that, or you're going to be, that's what you're thinking about. But what to the angles, the radian measurements that we have, that we know 0, pi over 6, pi over 4, pi over 3, pi over 2, and combinations of those. But we want a minus pi over 12. So what 2 do we use to get minus pi over 12? Well, it's pi over 6 and pi over 4, I think. Yeah. What you got to use to get minus pi over 12, it's going to be pi over 6 minus pi over 4. And then you convert everything to 12, right? This is 2 over 2, and this is 3 over 3. So then you get 2 pi, and notice it's all over 12, right? 2 times 3 is 6, 3 times 4. This is 2 pi minus 3 pi. So we have negative pi over 12. So these are the two, pi over 6, pi over 4. And you got your choice. You can use the difference where you use a positive pi over 6 and a positive pi over 4. Or you can use the sum where you use positive pi over 6 and a negative pi over 4. Right? Just like before. So which way do you want to think of it? It's got to be pi over 6 here. Now, do you want to do a plus, a minus pi over 4, or do you want to go a minus, a positive pi over 4? Whichever, it's going to make a difference on which one of your identities you use, right?
Yeah, but it's just, you're going to get the same answer.
You get the same answer. But I'm saying that when you put it down, you have to think of it as either plus a minus pi over 4, or you have to think of it as, a minus a plus pi over 4. And all I'm asking is, which way do you want to do it? You want to go plus a minus pi over 4? Okay, so you're saying, and if you do it this way, then what you're doing is you are doing a minus a plus pi over 4. Correct? So then your identity is going to be identity 2. The cosine, it's going to be this one, cosine of A minus B, where B is a plus pi over 4 and A is a pi over 6. So then you're going to use that second one, you're going to substitute into that cosine A, cosine B, plus sine A, sine B. So this is going to be cosine of pi over 6, cosine of pi over 4, plus sine pi over 6, and then sine pi over 4. And pi over 6 is going to be what? Square root of 3 over 2, isn't it? Pi over 4 is the square root of 2 over 2. This is 1/2. This is just like we did before. This is the square root of 6 plus the square root of 2 over 4. The important thing that that'll confuse you is which one are you gonna use? A plus B or A minus B? And then you better figure out what these things are. Are you using a positive or negative on these things? That's it. We can do, there's some more of these things that we need to do because we need to look at, you know, a couple more sections. But we'll do it Monday and then that'll be it.
When you say